This video is a brief introduction to general relativity, and a fuller treatment can be obtained from the electronic download available from lulu.com entitled General Relativity, a Concise Guide for Beginners. This is a sequel to the video clip on special relativity, which it is assumed the viewer has already seen. Here I have listed some of the problems with special relativity and how it could be applied in the circumstances of a gravitational field. Gravity is locally equivalent to acceleration, and therefore we need to extend the first axiom of Galileo's relativity so as to include such non-inertial frames. Here is depicted some of the notions which Einstein would have considered in trying to extend his special relativity into a more generalized theory, and we will look in more detail at how this was achieved. The mathematics of tensor calculus can allow us to deal with accelerating coordinates. However, there are extra problems when considering a real gravitational field which is only locally equivalent to an accelerating frame. So Einstein's key insight was, if a person falls freely in a gravitational field, he will not feel his own weight. In other words, we can effectively switch off a gravitational field by allowing free fall acceleration. So we might therefore deal with the problem of gravity by treating it as an accelerating frame of reference instead of a force operating in an inertial frame. The question arises, how do we incorporate the constant speed of light into this non-inertial frame? Einstein's initial attempts involved the realization that time slows down in a gravitational field, and these effects alone could reproduce Newton's law of gravity. However, he later realized that there was much more to consider when dealing with the gravitational field. Here in a little bit more detail is an outline of how we could equate the localized experience of a G field with time dilation by considering the two similar triangles there. He was able to show that he could predict what Newtonian physics would say about the deflection of light. to that of his own notions of time slowing down in the gravitational field. Later, however, he realized that this value he obtained of 0.8 seconds of an arc for light being deflected around the sun during an eclipse is only actually half of the fully relativistic value. So let's see why. Here is another one of his famous Gedanken or thought experiments. The bullet from the gun travels from A to B much quicker when it passes through the center of the planet due to the gravitational field. However, when the experiment is repeated by a beam of light, the light actually takes longer, even though special relativity states that the speed of light is constant for all local observers. The reason being is that gravity also warps space as well as causes a time dilation, and this has to be taken into account when he develops his final theory of gravity, general relativity. So there is a short summary of the situation so far. So as already mentioned, it's the mathematics of tensor calculus allows to do this, but the difficulty was in finding the exact equation, the field equation, which takes into account all the subtleties of a gravitational field. So let's look at some of these. One particular effect which is important, a subtlety of gravity, are tidal effects. Indeed, we are aware of these because the moon itself causes the bulge in the oceans around the world, which is manifests itself as the ocean's tides. This tidal effect is universal to gravity and needs to be accommodated in his field equation. So Einstein replaces the notion of a force with that of a warping of space-time. And there is the final equation that he arrived at. It is obviously too difficult mathematically to explain in such a short video clip. But on the right hand side is his field equations, which describe the curvature of space-time, and on the left hand side is the source of that curvature, which is described in terms of the mass, energy and indeed pressure. The latter of course becomes more important when we're dealing with astrophysical problems such as large stars and intense gravitational fields. And there is a brief summary. And much more detailed and explanations can be obtained from the web link shown below.